Good evening, everyone. Myself Gautam Sharma, and I welcome you all in a Sapience Education. So today we will discuss about the fourth part of the electrostatic potential as a capacitance. Basically, in this part, we will discuss about the basic principle of a capacitor, parallel plate capacitor, and its combinations. So hope you will enjoy this session. Thank you. Yeah, see here. Electric capacitors. So before that, you need to understand that what are the electric capacitors. So in market, you most of the motherboard you will see this type of capacitor. Okay, basically capacitor is just a storing device. Okay, it will store the energy in the form of a charge. See here, if you break the capacitor, so what will happen? There you will find two layers. See, two layers, anode foil as well as cathode foil. But admit there is an insulator, and due to insulator, what happens? It has the ability to store the charge, right? So most of the manufacturing devices or manufacturing process, what they do, they makes two layers and they will coil itself so that most of the charge will able to store at the mid of the insulator. Okay, so let us go ahead. Yeah, capacitor. Capacitor, it is a electrical device. It is a electrical device which can store energy in the form of a charge, right? So basically it is a device of storing the charge, only storing the charge. So storing a charge in such a way that it will create some energy. Okay, so let us consider there is a see, let us consider there is a plate. Okay, there is a plate and it has been kept in such a way that this is a insulator. So this plate has been charged with a plus charge, right? So what happen when you charge any plate with the positive? So what will happen? It has the ability to store the charge, positive charge, right? After that, when you put any other charges, any positive charge, so what will happen? It will leak. It will leak. It is just like a glass of water. You think about, imagine that there is a glass of water, right? If there is a glass of water and if you start pouring water, so what will happen? Its height or its capacity will increase, right? But after certain limit, that is, it has suppose limit of 2 liter. So after certain limit, so what will happen? Water will come out, so it won't able to store, right? Okay, so same is here, that if any conductor has the ability or has the capacity to store a charge of a 5 coulomb, so after that what will happen? It will start leakage. It will go outside the atmosphere and it will start leakage, or otherwise if it won't able to store anymore. So what we will do, we will create another plate. We will keep another plate, right? We will create another plate. See here, if we will create another plate, so what will happen? Due to induction, so what will happen? A negative charge will be induced here. Okay, so there will be a negative charge induction. Got it? Right, so negative charge will be introduced, right? Due to negative charge, what will happen? See here, earlier it has a potential of suppose V volt. Now what happened? Due to this here, minus V volt is being created, right? Okay, minus V volt is created on this plate, or we can say that there will be an opposite electric field will be created. After that, what will happen? Its capacity will increase, right? Its capacity or to store the charge will increase. Why so? Because due to this, what happens? There will be a creation of a, in this side there will be creation of negative charge, and due to which what happen? There will be a sudden drop of a potential. And if there is a sudden drop of the potential, it means that your capacity of storing a charge will increase, right? So I hope you will, and you now understood. Now the concept of the capacitance. When a conductor is charged, then its potential rise. The increase in a potential is directly proportional to the charge of the given conductor. Yeah. Let us suppose there is a conductor, and if you store a charge Q, plus charge, plus charge, plus charge, so what will happen? Its potential will also increase, right? Its potential will also increase. Now up to certain limit only you will able to store the charge. After that, what will happen? The charge will start leaking. If you increase the size of this container or this insulator, so what will happen? You can store more charge. The more charge you will store, the more voltage it will increase. For example, it has the maximum limit of voltage 5 volt, but here when we are storing a large capacitor, large capacity of the charge, so its in voltage will increase by 10 or 15 like this. It means that the whatever charge you are applying, so its voltage is also increasing at proportional rate. But the thing is that it depends upon the capacity also, right? So this is known as a constant of proportionality, which is called capacitance, and this C is known as capacitance of the capacitor, and the object in which we store the charge is known as capacitor, and its property or its constant is known as capacitance, right? So from here we can say that capacitance is equal to Q by B. The constant C is also known as capacitance of the conductor, and the SI unit is farad or coulomb per volt, right? SI unit is farad or coulomb per volt. Okay. Principle of capacitor. Whatever we have discussed, same thing is here. Let us consider an insulator metal plate A, and let some positive charge is given to this place till the potential become maximum, right? After that, what we will do? We will put another insulator here. And in this insulator, what will happen? There will be a negative charge will be there. Earlier, what was, see here? Earlier, what was the electric field? E was the electric field. But as soon as you put another conductor which is parallel to it, so what will happen? There will be a certain decrease in the voltage, and due to decrease, what happens? Its capacity increases. Its capacity increases, right? So in this way it works. Capacitor, it is the system of two conductors separated by an insulator, and it is an arrangement of for storing a large amount of electric charge and hence electrical energy in a very small space. So basically what we can construct a parallel plate capacitor where we can easily store the large amount of charge, and we can just put here an insulator so that the energy, the capacity of the capacitor can be increased. So we will go for some derivation as well as, right? A capacitor gets charged when a battery is connected across the plate, and once the capacitor gets fully charged, a flow of charge stops in the circuit. Let us consider there is a capacitor and it is being connected by a battery, right? Okay. So connected across the plate, and once the capacitor gets fully charged, flow of charge stops in the circuit, and the potential difference across the plate of a capacitor is same as that of the potential difference across the terminal voltage. So what will happen? It will become in such a way that, see, there is a positive and negative charge, right? So here also it will become positive, and one side it will become negative, and there will be also a equal amount of potential difference here also, right? Now capacitance of a spherical conductor. So if you want to find the capacitance of the spherical conductor, so what we will do? See, potential, we know that potential is equal to, we have already studied about the potential, how to find the potential, right? Potential in chapter number 1. So potential can be 1 by 4 pi epsilon naught into charge by radius, right? So here potential we can find like this. Now we can see, we know that the capacitance C is equal to Q by B. So just we put here Q by B. So when you do this, so what you will get? You will get the capacitance as 4 pi epsilon naught into R. Now if the medium, if, see, here we used E naught, means medium was vacuum. But if it is not a vacuum, so what will happen? See here, relative permittivity, what we have discussed in chapter 1 is what? A permittivity in the medium divided by permittivity in the vacuum. So so what we can do? So epsilon naught permittivity in a medium, it can be written as permittivity, relative permittivity into epsilon naught. So from here, we in a certain medium, if you want to find the capacitance of the spherical conductor, so you can write here 4 pi epsilon naught into R, that is your relative permittivity. That is your relative permittivity, right? Permittivity. So this is a relative permittivity. I hope you have understood now. So whenever you want to find the capacitance of a spherical conductor, so what will happen? Its radius is R. It has Q amount of charge. So what happens? C can be directly written as 4 pi epsilon naught into epsilon relative permittivity into R. You can see here that it does not depend upon how much charge is there. We don't know, but we can find the capacitance of the spherical conductor. Okay. Now let us go for capacitance. Also depends, capacitance depends upon the size and the shape of the conductor, but it does not depend upon the amount of charge, how much we store, as well as surrounding medium, presence of other conductor nearby. So these are the three things where the capacitance depends upon, right? Now let us discuss about the parallel plate capacitor. So let us consider there is a parallel plate capacitor, and it is consist of two metal plates of area A at a separation distance of d, right? So they have been separated by a distance d. Now the electric field between the plates is how much? See here, see, this is your sigma and this is your minus sigma. So the electric field will be equal to sigma by epsilon naught, right? Now we know that sigma is equal to charge by area, right? Charge per unit area is also known as sigma, right? Now the potential difference across the between the plate is how we can find the potential difference, right? See, this is your positive charge, this is your negative charge. So I hope you have understood. Now we have I have discussed in previous class, chapter, that dV by dr is equal to electric field. That is, electric field will decrease with the increase in the distance. This is your dV by dr. Let us write once more. Write once more. See here, dV by dr negative is equal to electric field. It means that electric field will decrease with the increase in the distance, and this is known as potential gradient. This is known as potential gradient, right? Now see here, so if we make a dv as a v, dr as a distance d, so we can write here electric field as like this. So from here we can find that voltage is equal to electric field into d. Now we have already derived that electric field is equal to sigma by epsilon naught. So we can put here sigma by epsilon naught into d. Now finally v is equal to what? V is equal to q by a into d. Why q by a? Because sigma is equal to charge by area, right? So we can put here charge by area into d by epsilon naught. So from here we will get capacitance is equal to q by v. Just you calculate by your own that how you can find this. See, very important. See, q by v. So just put the value of q and put the value of v. So you will get epsilon naught a by d. So from here what we have learned, we have learned that finally that the capacitance is of a parallel plate capacitance is equal to sigma epsilon naught by d. So capacitance of the parallel plate capacitance depend upon the permittivity as well as area of plate, right? And this is the distance between the plate, right? Distance between plate. I hope you have understood now. Let us go for next topic. Effect of a dielectric on a capacitance. Dielectric means what? You are putting some insulator like material, right? Where charge cannot be conducted. So when a medium is fully present between the plate, see, medium is fully present. For example, there is a plate and you have fully covered with the dielectric medium, right? Fully, you are not giving any gap. So when you are not giving any gap, so what happens? So this is the distance d. So what will happen? Electric field between the plates decrease by k, and due to which the v decreases by k, and due to which C medium will become K epsilon naught A by D. Now you are thinking that how it is possible. Let us discuss more elaborative manner, right? See here, initially epsilon electric field E naught is equal to, E naught is the initial condition, right? Sigma naught is your initial charge density. So what happened? E naught is can be written as sigma naught by epsilon naught. Also, let us consider the initial voltage was V naught. Initial voltage is V naught, right? So how you will find capacitance? So we know that the formula see here. First of all, E is equal to E naught is equal to V naught into D, right? No, it won't be V naught into D. C, sorry. It will be, let us clear it, right? Yeah, just you use this formula. See, always try to use this formula, gradient formula, right? So gradient means what? dV by dr is equal to E. So from here, dV is equal to E into d naught d distance. Okay, so use this formula. So from here we can finally tell that V naught is equal to E naught into d, and also Q is equal to CV naught, and all are initial conditions, right? All are initial conditions. So from here we want capacitance. So capacitance is equal to Q by V naught. So from here Q by V naught is how much? V naught is equal to E naught into D. Now what is E naught? See, Q by E naught is your in sigma naught into epsilon naught divided by D, right? So sigma is what? Sigma naught is equal to what? Charge by area naught, right? So charge by area naught. So charge by area naught Q in by Q into A into epsilon naught into D. So from here we can find that initial condition, initial capacitance is how much? Initial capacitance is how much? A into epsilon naught divided by D. Now I will discuss that when you insert a dielectric. So what happened? Dielectric medium. So there will be an orientation. What type of orientation will happen? See here. See in white color I am just discussing. So negative charge will come this side, positive come this side. See, automatically the molecular alignment will be like this. I hope I have discussed this thing. So what will happen when molecular alignment will become like this, and in this side also the molecular alignment will be like plus charge minus charge, plus charge minus charge, right? So what you see here, this earlier this charge was positive, and after that dielectric it's some part of the negative charge comes here. It means that the density decreases, right? Density decreases. So let us consider density is sigma naught minus sigma polarity, where sigma p means what? Charge density of the polarized molecule. Sigma p is charged molecule charge densities, charge density, charge density, density of polarized molecule. Okay, so sigma p is your charge density of the polarized molecule, right? So definitely due to polarized molecule decrease, there is a decrease in the density, charge density. Now let us go and discuss that what will happen. See, this was the initial condition without any dielectric. Now we have induced a dielectric. So what will happen? Let electric field become electric field is now E. So it will definitely change. So in case of sigma naught, we have to put sigma naught minus sigma p divided by epsilon naught. Now we can write this as a sigma by sigma naught by k, where k is the dielectric constant. Dielectric constant, and k is always greater than 1 for any insulator. It means that the density, charge density decreases. Charge density decrease by k amount, right? Now you have got this formula. Now we can impose. Now let us consider now voltage. So voltage will also decrease. In place of E naught, we can write here E into D. So in place of E, we have to write sigma by K into D. It means that the voltage also decreases. New voltage become sigma not D by K. So voltage decreases, right? So we have got voltage decreases. Now let us consider C naught. C naught is equal to Q by V naught V, right? So let us find now, find the values, right? Find the values, right? Let us put the values. Now the Q divided by V is equal to sigma naught into D, sigma naught into D divided by K. So this will become like this. So what happens? Q by sigma naught means what? Q by A. So this will be A into K, and I think yeah, one thing we are missing here, epsilon naught. Yeah, epsilon naught we are missing here, epsilon naught. See here, because electric field is equal to sigma by K into epsilon naught, right? K into epsilon naught, right? Why? Because we are considering new sigma as sigma naught by K times epsilon naught, right? So here also what will happen, we have to put here epsilon naught, right? So it will be like this, epsilon naught. So Q by Q into T. So we can put here into epsilon naught, right? Epsilon naught. Now Q got cancelled out. So what we will get, K times A epsilon naught into divided by D. Now what is A epsilon naught by D? So this is the initial capacitance, C naught into K. So finally what we have got, capacitance increases. So here capacitance increases with inserting a dielectric medium K times. Okay. So I hope you have understood now. Now let us go for case 2. Now case 2, case 2, when a medium is partially present between the plates. See here, the medium is present, but it is not fully present. It is present for thickness T, and the parallel plate capacitor has the distance apart is D. So for this case, what will happen? We need to see here, electric field outside the slab will be D minus T, in a space will be epsilon naught sigma by epsilon naught, and electric field inside the slab is sigma by K into epsilon naught, just we have studied. So net potential difference will be how much? So this plus this, right? E naught, because for E naught there is a gap, that is D minus T, right? And for T we have electric field as a T, because here only there is a decrease in the electric field, but for this gap there is no decrement in the electric field. So that's why final V is like this. So if you have got V, so from here we can find the V is, we can take the E naught as a common, so we will get like this. So put the value of E naught, so we will get here. So finally, our target is to find the capacitance. Final capacitance will be epsilon naught A by D minus T plus T by K. So this is the final capacitance. I hope you have understood now. Okay, but this will be this is the out of the syllabus. Of in spite if anyone asks that, you can directly answer this, right? When within a metallic slab inserted between the plate, if metallic slab is inserted between the plates, so what will happen? Capacitance will decrease. C will decrease directly. How much times? T times. If C, let us consider there is a capacitor, and in this gap we are inserting a metallic plate here having a thickness T. So what will happen? Capacitance will decrease directly. I hope you have understood now. Now the thing is that what is the energy stored in the charged capacitor? Okay. Now see, let us consider Let us capacitance of a capacitance C connected to a battery of a charge B, right? Let let battery supplies a small amount of charge dq. See, let us consider for an instant dq is here. This is plus dq and this is minus dq is small amount, right? So what will happen if there is a positive? See here, if there is a positive charge and this is negative charge, so what will happen? Electric field will be created, right? Electric field will be created. Now see here, earlier what happened, circuit electron was trying to go in this direction, but due to electric field electron will find a repulsion, right? So so what will happen then? The small amount of work done by the battery is, see, or when it creates an electric field internally, so what will happen? See, again you try to understand. If there is a dq charge plus dq charge, let us forget this. Let us think that there is an amount of dq charge plus dq charge and here is minus dq charge. So what will happen? It will set up a internal electric field, and due to which what happen, no electron will go in this direction, right? So there is certain amount of work is to be done against this electric field. So how much work is to be done? So work done is equal to V into dq. As you know that uh, potential is equal to work done per unit charge, that is dq. So from here we can find a dw, right? So in place of voltage, so we can write here charge by q, because after a certain time, let us consider, we are not thinking a small dq charge. After certain time, q total charge setup is q by c. So from here we got w is equal to dw is equal to q by c into dq, q by c into dq, right? Now we want to find total work done. So total work done, since why we have taken a small charge, because charge, when charge will increase, so what will happen? There will be voltage increment, and due to which what will happen, we have to do more work. So it means that work done depends upon the amount of charge here. So charge is already increasing variable, so that's why we need to integrate. So when you integrate d2 as a work done, so what will happen? You have to integrate q into dq by c. So when you see here q by c, and when it starts from zero charge to final charge, let us consider q charge, right? So when you integrate it, so you will get q square by 2 into 0 to q. So finally work done is equal to q square by 2c. So same work done. The work done is stored by the capacitor in the form of electrical potential energy. So electrical potential energy is equal to half q square by c is equal to half cv square is equal to qb. So it is very easy. So I hope you have understood now the potential energy. Now let us go for a next one. Combination of a capacitor. Now let us see here. Combination means what is? There are so many capacitors which is connected in either series or parallel in the circuit. So we want net or equivalent capacitance. As we have already discussed resistance, combination of a resistance, you know. In 10th you also you have studied. Here we will find a combination of a capacitance. So let me tell you that in a series what happens. See, try to observe the condition, then you will able to figure out the formula easily. In series combination of a charge, each capacitor is equal. Charge is equal. Why charge is equal? So let us consider a q charge is stored. So in this plate, minus q will be stored due to induction. And due to this, what will happen in this plate? Plus q will be stored in due to the induction. Minus q will be stored. Plus q minus q. So the everywhere the amount of charge will be equal, but the voltage will be different, right? Voltage will be different. In a series, amount of charge will be uh, constant, but voltage will be different. Okay, and capacitance may be different, right? So let us put here q is equal to c1 into b1, q is equal to c2 into b2 into c3 into bt. Now tell me, in series what is distributed, current or voltage? So definitely it is your charge or a current is not distributed, it is equal, but the voltage is distributed. So voltage can be written as v1 plus v2 plus v3, right? Now put the values of the voltage C. Let us consider C equivalent as net capacitance. This is equal to Q by V. So from here V will be equal to Q by C. So Q by C we have got. Now V1 can be found by this. So Q by C1. V2 can be found by this, Q by C2. V3 can be found by Q by C3. Now when you cut each Q, so what will happen? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So finally equivalent capacitance is equal to 1 by C1 plus 1 by C2 plus 1 by C3 is the process. So in series, it is series. If you want to find the equivalent capacitance, so you have to add it reciprocal way. But when you are adding in a series in a resistance, so you are not adding, you are adding directly. But in capacitor, it is just opposite to the resistance, right? So I hope you have understood now how to find the capacitance when it is connected in a series. Now let us go for a parallel capacitors. See capacitance in a parallel plate capacitor. See here. So this is your voltage, this is your voltage. So voltage will be same for each and every capacitor, because we know that in parallel voltage will remain same, but what we will get distributed, charge or current. So here charge is distributed, capacitors are different, right? Now we know that voltage V is equal to V1 is equal to V2 is equal to V3. Okay. Now what get distributed in parallel combination, potential difference across is capacitor is same and equal, but the total charge is shared by each capacitor. So total charge will be Q1 plus Q2 plus Q3, because we are giving Q, but it has been distributed in the form of Q1, Q2, Q3. So you can find here C. Let us consider that Cp is the total equivalent capacitance. So now tell me, in place of Q, we can write here capacitance Cp and voltage V. In place of Q1, we can write here C1 into V. Q2, we can write C2 into V, C3 into V for in place of Q3. Now everywhere V is common, so we cut it. So we will get Cp as C1 plus C2 plus C3. So when capacitors are connected parallelly, just you add on, you will get each and everything. Okay. So I hope you have understood this combination, right? So two things we have studied parallel. We have studied two things. First of all, combination of capacitor in series, that is 1 by Cas is equal to 1 by C1 plus 1 by C2 plus dot 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 1 by Cn. Now combination of capacitor in parallel. So this will be one. This will be directly Cp is equal to C1 plus C2 plus C3 dot 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 Cn, right? So I hope you have understood these things. So in this way we can end up the chapter. So we will meet again in the next chapter. So I hope you all have understood this and try to revise it. Whenever you are getting problem, just comment in the comment section so that we can be in a regular touch up. I am going to explain each and every chapter in series wise, so be updated. Please subscribe here so that you can find out each and everything in a proper manner. Okay, thank you for watching my video.